Alright, it's time for another math easy solution here to discuss further into trigonometric integrals and look at example 3 of the example series and cover this example, which states find the integral from 0 to pi of sine squared x dx. Now when we're looking at this integral or this function, it's hard, it's not that straightforward of finding this integral, and if we were to apply the common trig identity sine squared x plus cos squared x equals to 1, and basically rearrange this, if we were to write the sine squared x equaling to 1 minus cos squared x, this doesn't really get simpler, so it does not help us. Yeah, so basically this is not helpful. So yeah, from my earlier videos, basically in our early examples, we had an odd power of sine or cosine, and that basically enabled us to separate a single factor and convert the remaining even power. For example, from my last video, we basically had this function right here, sine to the power 5 times it by cos squared of x dx right here. Now we were able to, because it's an odd, take a sine out and write this remaining sine as sine squared power of 2, just so it becomes sine 4. Then there's a cos squared x, and then we would write that using the original right here, the identity, this one here, and write sine squared is 1 minus cos squared of x all squared, and then later we would use substitution rule, and then we would change this cos of x in terms of u, and so basically make sure to watch that. But in this case, if the integrand contains, or the function inside the integral, for example this, if it contains even powers of both sine and cosine, this strategy fails, as in our case. It's not an odd one, this is a even power of sine. So now, but in this case we can take advantage of the following half angle identities, which I covered in my last video, which are basically sine squared of x equals to 1/2 1 minus cos 2 of x, and then we have this one here for cos squared of x equals to 1/2 1 plus cos 2 of x. So make sure to watch my earlier videos on proof of these. This is called half angle because you start off with an angle x, and then which is basically half of the angle that's inside here. So 2x is double this one. So you're becoming so the identity is for half of the angle, which is x versus 2x. So now in our case we could apply this identity. So we have 0 to pi of sine squared of x dx. This equals 2, just rearrange it now, so 0 to pi of 1/2 1 minus cos 2 of x dx. And now we could just solve the integral right here. So this is going to be, well, 1/2 integral of 1 is x minus integral of cos 2 of x. That's going to be sine 2 of x, and we always have to think about the chain rule, so then we would have to divide by 2, because the derivative of sine 2 of x is going to be cos 2 of x, and then times it by 2, so we need to divide this out. Now from 0 to pi, so we can evaluate this. 1/2, put the pi in there, pi minus sine 2 pi divided by 2, and then this is going to be minus, again this will be 0 minus sine 0 divided by 2. So now we have this, sine of 0 is just 0, and also sine of 2 pi is just 0. So this will just be pi over 2, and that is our answer. And if we were to look at graphically what this means, draw this out, so x and y axis, the sine squared is going to look something like this. It's going to look like a sine curve, but because it's sine squared, it's always positive, so we'll go back up like that. So make this the same height, something like that, where at this point is pi, this is our 2 pi, and it keeps going on and on, but since we're dealing with 0 to pi, this is again sine squared of x. This is what we just evaluated. We evaluated basically the area underneath sine squared of x from 0 to pi, and this area is equal to pi over 2. And that's just basically what we solved using integral. Anyways, that's all for today. Hopefully you learned from this video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.